Let's determine draft forward corrected, draft mid corrected, and draft aft corrected. Straight away, let's discuss what is draft corrected. That is the draft at the corresponding perpendicular. Why do we need to know the drafts at the corresponding perpendicular, corrected drafts? Why we cannot enter the hydrostatic tables using the draft that we just simply read from the draft scales? Because all hydrostatic tables are designed to be entered with drafts at perpendiculars. But there is one problem. Our draft scales are not located at the corresponding perpendiculars. Why? Because it's not convenient to put draft scale at the corresponding perpendicular. For example, how can we imagine to put forward draft scale at the forward perpendicular? It's impossible. That's why there is a distance between corresponding perpendicular and draft scale. If the vessel has no trim, the drafts at the perpendicular or at the draft scale will be the same. But will the draft at, for example, forward perpendicular and at the forward draft scale be the same if the vessel has a trim? No, they will not be the same. As you can see, in our case, forward draft scale is located aftwards from forward perpendicular, and the vessel is trimmed by stern. As you can see, draft at the forward perpendicular is smaller than draft at the forward draft scale. If we have a look at the stern drafts, then we can see that draft at the aft draft scale will be smaller than the actual draft at the aft perpendicular. And our goal is to get draft at the perpendicular when we know the trim and when we know the draft at the draft scale, and we will also know the distance between the draft scale and perpendicular. To get the draft at the perpendicular, we need to find the difference between draft at the draft scale and draft at the perpendicular. And that difference between those two drafts is called draft correction. So we need to find forward draft correction, mid draft correction, and aft draft correction. So how are we going to do that? First of all, we need to enter the stability booklet and we need to find a drawing of the draft scales. As you can see, there is such a drawing where we can get the distance between the perpendicular and draft scale. For example, here is the forward perpendicular and here is the forward draft scale. And we see that the distance between forward perpendicular and forward draft scale is 3.1 meters. There is midship plane and there is middle draft scale. As we can see, the distance between them is 0.84 meter. And let's have a look at the stern part of the vessel. We can see aft perpendicular and we can see aft draft scale. The distance between them is 10.48 meters. That is the simple case when we have only one draft scale at the stern. Sometimes we may have two or even three draft scales at the stern. And you need to be careful when performing draft survey calculation to get the distance from the aft perpendicular to the actual draft scale from which you actually read the draft for that draft survey calculation. And there is one more important for us value is LBM, length between marks. In that case, that is 171 meter and 42 centimeters. What is that figure? That is the distance between forward and aft draft scales. I will point your attention once again that in that case we have only one stern draft mark, but there may be the case when you have, for example, two or three aft draft marks. In that case, you will have two or three LBMs, lenses between marks, because your draft scale will be located somewhere here, so the distance between the forward and aft draft scales will be, of course, different. You may calculate length between marks by yourself if you know lengths between perpendiculars and if you know distances between aft perpendicular and aft draft scale and forward perpendicular and forward draft scale. I think it's quite logical how to calculate LBM, but normally we just get it from the drawing. So if we know apparent trim, if we know from the drawings the distances between draft marks and corresponding perpendiculars, and if we know lengths between marks, can we calculate that draft corrections? The draft correction is basically, as I have already mentioned, the difference between the draft and the perpendicular and the draft and the corresponding draft scale. So let's have a look at the aft drafts. We need to calculate corrected aft draft, that is the draft and the aft perpendicular. But we know the draft and the aft draft scale. We do not know that draft. We need to calculate it. So to calculate that draft, we need to find aft draft correction. In that case, aft draft correction will be with the sign plus, because we see that draft at the aft draft scale is smaller than corrected draft, than draft at the aft perpendicular. So how can we calculate that aft correction? We need to refer to the simple trigonometry. Let's have a look at the triangular BAC. We know that if we multiply leg AC by tangent of that angle, we will get aft correction. Aft correction, that is leg AB. What is leg AC? That is aft distance to aft perpendicular. That is 10 meters and 48 centimeters. We know that figure. So we need to multiply aft distance to aft perpendicular. We need to multiply it by tangent of that angle. And what is that angle? That is angle of trim. So how can we get angle of trim and how can we get tangent of that angle? It is very simple. We know LBM, length between marks, and we know vessel's trim. Vessel's trim is the difference between forward draft and aft draft. That is our trim. Let's have a look at triangular CDE. Leg DE is exactly vessel's apparent trim, and leg CD is length between marks. We know what is the length between marks. We took that figure from the drawing, and we have already calculated vessel's apparent trim. And as we can see, those two angles, they are the same, and they are the angle of vessel trim. Can we get tangent of that angle from triangular CDE? Yes, we can get it. How can we get it? Tangent of that angle equals to leg DE divided by leg CD. Leg D is trim, leg CD is LBM. So that means that tangent of that angle, tangent of angle of trim, equals to trim divided by LBM. And then, if we multiply aft distance to aft perpendicular by that tangent, we will get aft correction. So the formula for draft correction is the following. Distance to perpendicular multiplied by tangent of trim angle. And tangent of trim angle is calculated as apparent trim divided by length between marks. So that is how that formula appeared. Let's come back to the aft draft correction. Aft draft correction equals to distance from the aft perpendicular to the aft draft scale multiplied by vessel apparent trim and divided by length between marks, between forward and aft draft scales. Let's perform calculations for our example. Let's calculate aft draft correction. We know that the distance between aft draft scale and aft perpendicular is 10.48 meter. We know that apparent trim is 2.03 meters, and we know that length between marks 171.4 42. What is the value of updraft correction? Let's use that formula. Updraft correction equals to distance between updraft mark and perpendicular multiplied by trim divided by LBM. Let's just put our figures inside that formula. So 10.48 multiplied by trim 2.03 and divided by LBM divided by 171.42. That is the answer, 0.1241 meter. Let's calculate the values of draft corrections for initial draft survey if forward distance to forward perpendicular is 3.1 meter and distance from the midships plane to the middle draft scale is 0.84 meter, 84 centimeters. So we will use the same formula, and what we get. Forward draft correction equals to 3.1 multiplied by vessel apparent rim and divided by length between marks equals to 0.0367 meters. Mid-draft correction distance 0.84 multiplied by vessel apparent rim by 2.03 and divided by 171.42, that is our length between marks. So mid-draft correction equals to 0.0099 meters. I believe that you have a question which signs those draft corrections should have. Why we did not apply any sign when performing those calculations. For example, if forward draft scale is located upwards from the forward perpendicular, it should be with the minus or plus sign. And for example, if we talk about stern draft, if stern draft scale is located forward from the aft perpendicular, should we take that figure with plus or minus sign? I would suggest not to rely on the plus or minus signs rules. I would suggest to split that calculations into two parts. First of all, we just calculate draft correction without sign plus or minus. And then, once we have calculated forward, mid, and aft draft corrections, we will determine the sign, whether it is minus or plus. So at the moment, let's finish with the calculations of the values of draft corrections. For initial draft survey, we have done already. Now let's perform those calculations for the final draft survey. We will not take into account the signs, just the figure without the sign. So for the final draft survey, we have apparent trim minus 0.92 meters. We have trim by stern, and we need to calculate the draft corrections for the forward draft mark, for the midship plane, and for the aft draft mark. I will remind you the formula. Draft correction equals to distance to perpendicular multiplied by apparent trim divided by LBM. That is our LBM. I would suggest to pause the video, perform the calculations on your own, and let's share the results. I have the following answers. Forward correction for the final draft survey is 0.0166 meters. Mid correction is 0.0045 meters, and aft draft correction is 0.0562 meters. As you can see, the bigger trim and the bigger distance between the draft mark and corresponding perpendicular, the bigger draft correction. And now, after the values of draft corrections are known, we must determine the sign of draft correction, whether it is plus or minus.